Right now, Venus is the hottest planet in the solar system, not Mercury, which orbits twice as close to the Sun. Venus, its surface temperature holds steady at around 465 degrees Celsius, hot enough to melt lead, hot enough to destroy a spacecraft within hours of landing. The atmospheric pressure at the surface is 92 times that of Earth, the equivalent of being submerged almost a kilometer underwater. Acid clouds made of sulfuric acid cover the planet from pole to pole. No sunlight reaches the surface directly. No rain falls that isn't corrosive. No wind moves at the surface that isn't carrying heat. But scientists now believe Venus may once have looked surprisingly similar to Earth. So what happened? The twin that wasn't. For most of the history of planetary science, Venus and Earth were treated as opposites. Same size, similar mass, similar distance from the Sun at formation, but completely different outcomes. The assumption was that they had always been different, that Venus had always been this way. That assumption began to crack in the 1980s when NASA's Pioneer Venus mission detected something unexpected in the planet's atmosphere, a ratio of hydrogen isotopes that suggested Venus once had a significant amount of water. Not vapor, not trace amounts, enough to have covered the surface. For decades, scientists thought Venus and Earth evolved completely differently. Now they think Venus may have started as Earth's twin. NASA's Goddard Institute for Space Studies ran climate simulations of early Venus using the same modeling tools used to study Earth's atmosphere. What they found was striking. With an atmosphere similar to early Earth's, ancient Venus could have maintained a shallow liquid water ocean and habitable surface temperatures for up to 2 billion years of its early history. 2 billion years. That's longer than it took for complex multicellular life to appear on Earth. The implications were difficult to ignore. Ancient Venus, in the right conditions, may have been not just habitable, but genuinely Earth-like. Clouds forming over its oceans, rain falling on its surface, temperatures stable enough for liquid water to persist across geological timescales. And then the planet began to change. What Venus became. Before tracing what went wrong, it helps to understand what Venus is now, because the gap between what it may have been and what it is today is the most disturbing part of this story. The surface of Venus has been mapped almost entirely by radar, because no optical instrument survives long enough to photograph it. The Soviet Union's Venera probes, the only spacecraft to ever successfully land on the surface, transmitted data for between 23 minutes and 2 hours before being destroyed by the heat and pressure. The landscape they revealed before dying was volcanic, vast plains of hardened lava, mountains and highland regions, a surface geologically young by planetary standards, resurfaced, scientists believe, by a catastrophic volcanic event roughly 700 to 800 million years ago that buried whatever terrain existed before it under kilometers of fresh rock. Whatever happened to Venus, it erased the evidence. Venus didn't become hell overnight, but whatever transformed it did so thoroughly enough that almost nothing from its earlier history survived. The moment control was lost. The leading explanation for what destroyed Venus is a runaway greenhouse effect, a process that, once started, cannot be reversed. Here is how it works. Venus receives about twice the solar radiation Earth does, simply because it orbits closer to the Sun. In its early history, the planet may have been able to manage that energy. Cloud cover reflecting sunlight back into space, oceans absorbing heat, a carbon cycle keeping atmospheric CO2 in check, a balance, fragile but functional. But as the Sun slowly brightened over billions of years, the balance shifted. More heat reached the surface, more water evaporated from the oceans. And water vapor is itself a greenhouse gas. It traps heat. More heat evaporated more water vapor trapped more heat. The planet slowly lost control of its own atmosphere. Once ocean temperatures rose past a critical threshold, evaporation outpaced any mechanism that could have absorbed the excess vapor. The oceans didn't gradually shrink, they boiled. And once that process began, the planet could no longer cool itself. The water that had taken billions of years to accumulate entered the atmosphere as steam and never came back. The part that should unsettle you. But this is where Venus becomes terrifying. because some scientists think the same process could theoretically happen to Earth. Not tomorrow, not in any human time frame. The models that describe a runaway greenhouse on Venus place that threshold at a level of solar radiation Earth won't receive for hundreds of millions of years as the sun continues to slowly brighten. But Venus didn't reach that threshold because of anything unusual. It reached it because it was slightly closer to the sun, received slightly more radiation, and crossed a line that, once crossed, could not be uncrossed. The line exists. Earth sits on one side of it. Venus crossed to the other, and once Venus crossed it, there was no way back. An entire ocean gone. As Venus's water evaporated into the atmosphere, something else began to happen above the clouds. Ultraviolet radiation from the sun struck the water vapor molecules and broke them apart, separating the hydrogen from the oxygen. The hydrogen, being the lightest element, escaped to space. The oxygen was absorbed by surface rocks. Slowly, irreversibly, Venus lost its water not by leaking it into the ground, but by having it dismantled by sunlight and scattered into space. An entire planet was slowly being sterilized. The process took millions of years, possibly hundreds of millions, but the direction never reversed. Each molecule of water that reached the upper atmosphere was destroyed. Each hydrogen atom that escaped to space was gone permanently. The ocean shrank, the steam thickened, the surface temperature climbed, and the carbon dioxide that had once been locked in surface rocks and oceans, the same carbon cycle that keeps Earth's atmosphere breathable, was released back into the atmosphere with nothing left to reabsorb it. By the time it was finished, Venus had lost its oceans, its carbon cycle, its habitable temperature range, and any chance of recovery, all without a single asteroid impact, without a nearby star-going supernova, without any catastrophe arriving from outside. It destroyed itself with physics. What the heat did next. With the oceans gone and carbon dioxide dominating the atmosphere, the surface of Venus entered a phase of escalation that has never stopped. The thick CO2 atmosphere acts as an almost perfect insulating blanket. Heat from the sun enters but cannot escape. The temperature kept climbing, past 300 degrees, past 400, eventually settling at the 465 it holds today. At that temperature, any water remaining in surface minerals was baked out. Any carbonate rocks that might have reabsorbed CO2 were too hot to function. Volcanic activity, still ongoing on Venus today, pumps additional sulfur dioxide into the atmosphere. That sulfur dioxide combines with the trace water vapor remaining above the clouds to form sulfuric acid, the acid that now makes up the planet's cloud layers. Venus became a world trapped inside its own heat, and the longer it stayed that way, the more irreversible the trap became. What scientists found when they looked closer. The more scientists studied Venus, the stranger its past became. In 2024, a team at the University of Cambridge published a study that challenged the habitable Venus hypothesis entirely by analyzing the chemical composition of Venus's atmosphere, specifically the ratio of gases that indicate what the planet's interior is made of. They concluded that Venus's interior is too dry for there ever to have been enough water for oceans to form at the surface. Not that the oceans evaporated, that they may never have existed. That conclusion is still contested. NASA's Pioneer mission detected chemical evidence suggesting Venus once lost enormous amounts of water. The GISS climate models showing stable habitable conditions for 2 billion years haven't been invalidated, and the ESA's upcoming Envision mission, launching in the early 2030s, is specifically designed to look for chemical evidence of ancient water in Venus's rocks and surface chemistry. The debate is open, the evidence is incomplete, and what's most unsettling is that both possibilities are disturbing in different ways. If Venus once had oceans and lost them, that is a warning about planetary fragility. If Venus never had oceans at all, then two planets form from nearly identical materials in nearly identical conditions and produce completely different results. And we still don't know exactly why. Two planets, one question. Earth and Venus formed at roughly the same time, from roughly the same materials, in the same solar system. One of them has liquid oceans, a breathable atmosphere, a functioning carbon cycle, and complex life that has existed for hundreds of millions of years. The other has a surface hot enough to melt metal, an atmosphere that crushes spacecraft, acid clouds from pole to pole, and a geological record so thoroughly erased that scientists are still debating what it once looked like. The difference between them is not dramatic. It is orbital distance. It is the amount of sunlight received. It is the position of a threshold that, once crossed, led in one direction only. Venus may be the clearest warning the solar system has ever given us, not because of what it's telling us to do, but because of what it reveals about how narrow the conditions for a living world actually are. What we still don't know. Scientists still don't fully understand how fast everything changed. The volcanic resurfacing event 700 million years ago may have been the trigger or the consequence. The models disagree on the timeline. The evidence from the surface is buried under lava. The atmospheric chemistry is ambiguous enough that two serious research teams can look at the same data and reach opposite conclusions about whether liquid water ever existed there. Envision will help. The Da Vinci mission, a NASA probe designed to drop through Venus's atmosphere and sample it on the way down, will help more. But the full picture of what Venus once was and how quickly it became what it is now remains incomplete. The light in the evening sky. Tonight, Venus will appear in the sky as a bright and beautiful point of light, the second brightest object in the night sky after the moon, often the first star people notice at dusk, a steady, brilliant white that has guided navigators, inspired mythology, and anchored calendars for thousands of years. Beneath those clouds is a surface no human will ever stand on, a landscape of volcanic plains and crushing heat that has been sealed from observation for most of the planet's history, a world that may have once had rain and clouds that weren't acid, and temperatures that could have sustained something. And whatever it once was, whether Earth's twin or always its opposite, it is now one of the most hostile worlds in the solar system. Venus may be the clearest warning the solar system has ever given us, not about what we're doing, about what physics does on its own, to worlds that cross the wrong threshold, at the wrong time, by the wrong amount. The difference between Earth and Venus may not be as large as it looks from here. Do you think Venus once had oceans like Earth? Let me know what you think in the comments. There are still planets, stars, and mysteries in the universe that we barely understand, and the deeper we look, the stranger everything becomes. Subscribe if you want to keep exploring.